So here, what is the sum of the measure of the interior of a triangle? So what's the sum of the interior of a triangle? 180. Yep. If you guys forgot, it's right here on this blue poster. Okay, which kind of triangle has all three sides congruent? Equilateral. Okay. Determine whether the grid shows a reflection on the x-axis, the y-axis, or neither. It's going to be the y. You see, if you folded it over the y-axis, it would lie on top of itself. And then determine the number of lines of symmetry. It's been a little while before we did this. Does anybody want to take what they wrote down? It's the y-axis. And then, so lines of symmetry, remember, that's where you fold it and it would lie on top of itself. So we know we have 1, 2, 3 going through the vertices. But we also have groups that go straight through the middle. So we have 4, we have 5, and we have 6. So if you fold them straight down the middle of any other side, it would lie on top of itself. So 6 is the answer there. Okay, so the first thing up says you want to be able to identify and classify polygons to be able to find the angle measures of quadrilaterals. That's our objective for today. So a polygon in itself is a closed figure in a plane that's formed by 3 or more segments called sides. I have one more clause that we put in there. The sides cannot intersect. So sides do not or don't intersect. So I'd add that in. So if you're looking at these examples, is this one formed by segments? Yep. Or is it closed? Yep. Do the sides intersect? So they don't officially intersect, they just meet at the endpoints. So we know that this is a polygon. What about the second one? Are the side segments? 3 of them are, but what about this one? This one, yep, is not. So that is not a polygon. Over here, you see that's formed by segments. It's closed, and those sides don't intersect. And the same thing with the third one. So only the second one's not actually a definition of a polygon. And then the last one is diagonal. It's a segment that joins 2 non-consecutive vertices in a polygon. So kind of what we started drawing is the first group of lines of symmetry. And our last one were the segment or the diagonals. I'm just drawing it here so you can see it. It's connecting those non-consecutive vertices. So this one has 2 diagonals. So when we classify polygons by the number of sides, some of these are very familiar with you. So 3 sides, triangle. 4 sides, quadrilateral. You guys may have seen these 2. So 5 sides, pentagon. 6 sides, heptagon, hexagon. 7 sides, heptagon. 8 sides, octagon. Nongon is 9 sides. Decagon is 10. And then n-gon is for anything above that. You just attach the gon to it. So 37 gon, 103 gon. 16 gon. Some of those may have specific names, but I'm going to allow you guys just to put the gon with it. Okay, so the Quadrilateral Interior Angle Theorem is that the sum of the measures of the interior angles of quadrilateral is 360. So before we've had 180 for triangles, but 360 for quadrilaterals. And then we wanted to identify if these figures are a polygon. So our first one up is the sides formed by segments. Are the sides formed by segments? No, so not a polygon. No, sides aren't segments. Okay, our second one up. Are the sides formed by segments? Yes. Is it closed? No. Part of it's closed. I mean, the other part arguably isn't. Do the sides intersect? No. Yes. Yep, so though it means this is not a polygon. And then our third one here is going to be, are the sides formed by segments? Is it closed? Do the sides not intersect? No. Yep, the sides don't intersect, so yes, it is a polygon. Now we're going to name it, so we have to count the sides. So 1, 2, 3, 4, 5. What do we call something that has 5 sides? Pentagon. Okay, so are the sides segments? Yes. Is it closed? The sides intersect? No. So yes, it is a polygon. So yes, now we have to name it. How many sides does this have? 4. What do we call a 4-sided object? You weren't here for it. That is a specific type of these. That's not the one we're looking at. Quadrilateral. Eventually we'll be talking about this chapter. Our next one up, is it formed by segments? No, not a polygon. Not segments. Okay, and then C. Is it formed by segments? Yes. Is it closed? Yes. Do the sides intersect? No. Nope. So it is a polygon. We got to count how many sides it has. How many do we have? 5. What do we call a 5-sided object? Pentagon. And then the last one we're going to skip. Over here, what's the sum of the interior of a quadrilateral? 360. So what we can do is we can do 360. And then we can subtract the angles we have. So minus 45, minus 150, minus 150. Which is the same thing as 360 minus 345. So what do we get? 15 degrees.